Now we are going to investigate some implications of the advice that we received. And for a while, it will not be very clear to you why we are doing or where we are going. In the end of the meeting or the recording of the meeting, you will fully understand that it is very useful. But for a little while, just try to understand the implications without yet knowing what we are going for. Some notation to prepare. Throughout this course, not only today, but all the meetings, subscripts will always refer to the states of nature. So S1, X1, the subscript 1 refers to state S1. Other indicators, superscripts, they refer to other things. For instance, if I want to distinguish between different choice options, X1, X2, I use superscripts to do it. For instance, in the street vendor example, X superscript 1 and X superscript 2 can indicate different merchandise, so different triples of numbers, different choice options. For instance, X superscript 1 can be this triple here. And here you have the first coordinate, the second coordinate, the third. The subscripts describe the outcome for the states of nature, so they do refer to states of nature indeed. X2, superscript 2, similar notation. So that's a notation that we will use throughout. With that understand a theorem, I say if I have x1 preferred to y1 and if you prefer x2 to y2, then this is preserved under summation, that is x1 plus x2 is preferred to y1 plus y2. That is one implication of the advices. So of transitivity, monotonicity, and additivity. They imply this. You can pause the video now and try to prove it by yourself. Then when you're done, come back. Okay, so now I assume you're done and you're back again, so I'll show you one of the proofs, a few ways, one is equivalent. But one way to prove is we start with the preference x1 weakly preferred to y1. And we use additivity. With additivity, you have to have the same z to left and right side. We're going to do x2 in the row of z. So we're going to get x1 plus x2 is preferred to y1 plus x2. We're going to do a similar thing with the other preference, x2 preferred to y2. Here z will be y1, as you will see. So we add y1 to both sides. We get x2 plus y1 is preferred to y2 plus y1. And then I can rewrite that because y1 plus x2 is the same as x2 plus y1. Here is similar. You can change them, it doesn't matter. So we get this preference. And then transitivity will bring us home because we now have, by transitivity, we have x1 plus x2 is preferred to this thing, but this thing is preferred to y1 plus y2. Transitivity says x1 plus x2 preferred to y1 plus y2, and that completes the proof. Now a more general theorem, I can do it not only 2 times, but 20 times. In fact, any natural number, 150 if I like. But let's do it for 20 now. Imagine I have 20 preferences like that, so not 2 in the previous theorem, but 20 now. I can sum all 20 and preference is preserved. So that's what this theorem says. You can again pause the video and try to prove. And I assume that you did what you want to do and you're back again. So I'll show you how one way to prove it. By the previous theorem, we already know that for twofold summation it works. So we know that x1 plus x2 is preferred to y1 plus y2. That is what the previous theorem told us. We add the preference x3 preferred to y3. We have 2 preferences is preserved under the summation. So we sum and we get x1 plus x2 plus x3. The sum of these 2 is preferred to the sum of these 2. We can then add the x4, y4 and go on like that and up to 20. Just keep on doing it and this result follows. It follows for 20 preferences, follows for any natural number of preferences. That preference is preserved under summation, so to say. So that is an implication we have accepted from our advisor that we want to satisfy transitivity, monotonicity, and additivity. Then we should also accept this implication. We want to satisfy it. Now imagine you are in a particular situation. You have preference that you thought about very well. You really think these are really my preferences. You thought well about them. You have x1 preferred to y1, x2 preferred to y2, and you have, let's say, m preference xm preferred to ym. You're going to do some calculations to see how things are. You're going to calculate how much the preferred X options give under state S1 and how much the dispreferred Y options give there. You do the calculation and you find that your preferred options in total give you less money on S1 than the bad guys. So you're a bit worried, wait a minute, the X's should be good, not bad. But then maybe probably X's are better state 2 and state 3. So then make up there. Now you're going to verify for state 2. But imagine that in this situation that for the state 2 you find the same. The good X's in total give less than the bad Y's. You're getting a bit worried. Can it be, are your preferences really good? Or probably maybe for state S3 the X's are much better than the Y's, so they make up for everything. You do the calculation. Now imagine for state 3 you find again the X's in total give you less than the Y's. This feels weird and not good. All the X's are good, all the Y's are bad. Still, whatever happens in total, these good things give less than the bad things. Doesn't feel good. I'm getting worried. Right, so, because I claim now that if you have such a situation, so these preferences, but if you add for every state of nature, you're worse off with the good things, I claim that you are violating the advice of the advisor. You're violating transitivity, monotonicity, or additivity. You can pause the video and try to find the proof again. And I assume you did what you want to do. You're back again. Now I'll explain to you why these preferences must imply that you are violating the advice. Because we have seen the theorem, if we have these m preferences, that means x1 plus xm is preferred to y1 plus ym. We saw that. Preference is preserved under the summation. So the sum of the x is preferred to the sum of the y's. But if we look here and we think about monotonicity, the sum of the x's for every state of nature give you less money than the sum of the y's. That means by dominance, monotonicity, remember, you should prefer the y's to the x's and not the x's to the sum of the y's to the sum of the x's, not the other way around. So you have a contradiction. On the one hand, the sum of the x should be preferred to the y's. On the other hand, the sum of the y's should be preferred to the sum of the x's. Cannot be contradiction. So you must be violating one of those conditions. But this is a very particular way of violating those conditions, a combination of monotonicity and additivity, transitivity also. If you violate the condition in this particular manner, then we say that there is a Dutch book in your preference system, or that arbitrage can be made against your preference system. So if arbitrage can be made against your preference, it means you're violating transitivity or monotonicity or the additivity condition. You're violating the advice of your advisor. Okay, so now we derived a few implications of the advice of these preference conditions. And now I will come to a result that follows from it that will be interesting. So what it all was serving for. That will be in the next recording.